Hello, class. I'm going to go over the statistics section 10.1, which is called scatter plots and correlation. And so let's see. Um, First thing I want to show you is remember our study guide here for your quiz number 2, which will contain 7 problems in time for 65 minutes and Connect Math. So remember, you're allowed one double-sided note page. So we're already up to this point where we're discussing now the problem on the quiz pertaining to number 7 and chapter 10, section 1. So these are things that we'll be talking about today, and these 2 problems that we'll be showing you to demonstrate this section. Stating the hypothesis, selecting the correct scatter plot from the provided data, computing the correlation coefficient, which we'll call R, to the correct place value requested, finding the p-value, probability value, to the correct place value requested, testing its significance at the given alpha level given, determine the null hypothesis, if that needs to be rejected or not rejected, and then explain the type of relationship. Is it significant or not significant? Okay, so this is what we'll be discussing today. And then just a reminder, with our course SLOs from our syllabus, this is related here to number 7, where we're solving problems involving correlation problems. And we're also going to be performing hypothesis testing using statistical methods. Okay, so this is what we're going over today. This covers that part, okay, of your SLOs. And in your workbook, this is from your workbook. This is on page 54 of your workbook. And from 54 through 57, there aren't any problems in the workbook. So I'm going to go through, there's a lot of reading though, and these problems that we're going to do today, you need to make sure that you have this printout from your Canvas course and your modules related to quiz number 2 material. There is a handout that is, let's see what it looks like. Looks kind of like this. Chapter 10, section 1. And this is double-sided. 1, 2, 3, 4, 5, 6 pages here. But you see, you need these problems, these 2 problems we're going to work on today. And that you get that from your Canvas course, and you want to print that, have that out, because these are the ones we're going to work on, 14 and 16 from your ebook. But let me go through and read what your workbook has. Okay, so it says here, introduction. It says that in addition to hypothesis testing and confidence intervals, inferential statistics involves determining whether a relationship between 2 or more numerical or quantitative variables exists. Correlation is a stats, right, method used to determine whether a linear relationship between variables exists. Okay. The purpose of this chapter is to answer these questions statistically. Are 2 or more variables related? And if so, what's the strength of the relationship? What type of relationship exists? What kind of predictions can be made from the relationship? Okay. And it says, number 1, are 2 or more variables related? And then if so, what is the strength of the relationship? So it says to answer these 2 questions, statisticians use the correlation coefficient, which is a numerical measure to determine whether 2 or more variables are related and to determine the strength of the relationship between or among variables. Okay, so it says what type of relationship exists. So there are two types of relationships, simple and multiple. In a simple relationship, there are two variables, an independent variable, which is oftentimes called a predictor variable, that's usually along the x-axis, and a dependent variable, which is a response variable, and that can be found along the y-axis. So we talked a little bit about independent, dependent variables earlier for our quiz 1, and we're trying to determine in a phrase or a statement which was considered the independent and which was considered a dependent variable. So we have a little bit of experience with that. That was on our first quiz. Um, in a multiple relationship, there are two or more independent variables that are used to predict one dependent variable. So we won't see any of these today that have two or more independent variables. We'll have more of the first one, okay? And it says what kind of predictions can be made from this relationship. So predictions are made daily in all areas. Examples include weather forecasting, stock market analysis. So, recently the stocks had gone down uh, severely, right? Quite a bit. Sales predictions, crop predictions, gasoline price predictions, sports predictions. Some predictions are more accurate than others due to the strength of the relationship. That is, the stronger the relationship is between variables, the more accurate the prediction is. Okay, so let me just, before I go to the second page, let me just show you what some of the questions will look like. Let me enlarge this from your ebook. See, they'll have us draw the scatter plot for the variables. So we did that recently in our previous section, your previous homework 2.4. So we'll start off with that, uh, making a scatter plot for our data. And that's why we jump from 2.4 to the 10.1, because it covers the scatter plots, okay? So we go ahead and do this 10.1 right after 2.4. We want to compute the value of the correlation coefficient. You want to state the hypothesis. You want to test the significance of the correlation coefficient at alpha equal 5 hundredths. So this is tenths hundredths place, and we won't use the table. This is going to be using the TI 84 plus graphing calculator. Okay. Now, keep in mind that this is the first semester that we are allowing the apps, the TI-84 apps. So I'm not sure. We've never used the apps before. I've always used the actual TI-84 plus calculator. So I'm not sure exactly how closely the steps are to your app. But if you find as I'm going through these steps today on the calculator that there are some discrepancies, then you need to plan to go to MathWorld right away, touch base with the MathWorld stats tutors to see if they can help you figure out, what to use in lieu, or to best, produce the results that we need. Okay, because this app idea is something that's totally brand new, and so I've alerted MathRo already so they can be ready to assist with that on the for the apps. Okay, but then you also want to give a brief explanation of the type of relationship and assume all assumptions have been met. Okay, so we'll talk about the assumptions on our handout. Okay, so we'll do problem 14 and 16 in just a bit. 16 has to do with state depth and per capita tax. 14 has to do with forest fires and acres burned. And so there's a lot of concern going on right now in California with a lot of the forest fires going on. So many acres have been burned. Okay, we'll go over that in a little bit. Okay, so this is also in your workbook. Mine's just got a yellow hue to it. When I made my copies, I had this yellow paper at hand. So yours is, when you make your copies, it will be in your white. So this is okay. So here on this page, it talks about, we went over chapter 2, section 4, scatter plot. So it just says, it's reminding us what a scatter plot is. It's a graph of the ordered pairs x and y of numbers consisting of the independent variable x and the dependent variable y. So here we have some problems here where they've already they have a picture of a scatter plot. So here they have these car rental companies they've constructed a scatter plot for the data shown for the car rental companies in the United States for a recent year. So they have created that. We're going to do something similar on our calculator. Let's see what they use for the x's. If I just subtract, let's see, if I subtract here 17.5 minus 8.5, right? Looks like they're doing increments of 9. If I come over here, 62.5 minus 53.5, see, increments of 9. So for their x-axis, they've used increments of 9. Every tick mark is increased by 9 units, okay? And as far as the y-axis go, if I subtract 2.75 minus 1.5, that's 1.25. When I check this last one, 7.75 minus 8 point, what is that? Let's see, 6.50. I said these are increments. The y-axis, each tick mark is an increment of 1 and 25 hundredths. Okay, so just to be aware of that. So, and let's see. So this is your revenue in billions of dollars, and this is your cars in thousands. But this does look like to have like a positive linear relationship. It does look like you're walking upstairs, right? Kind of have this idea that you're walking upstairs from left to right. Okay, so it looks like it does look like it has a positive linear relationship. Okay, and that's kind of when we do these problems, we'll start with a scatter plot just to get a feel to see if there's any type of relationship that appears to be taking place. But then you will further explore that direction by looking at the correlation coefficient and then testing the significance using a decision rule for the correlation coefficient at a certain alpha level. And then you'll make a determination about the relationship of the variables using statistical methods. Okay, so um, so we start off with the scatter plot. I'll starts with the scatter plot. If you look at the second example, we did something very similar to this in section 2.4 with the example we had was talking about the author of your ebook, Alan Blumen, and he was talking about he had randomly sampled students, also looked at their absences and like their final grades. And that's exactly what's happening here for this data, the number of absences and the final grades. And this was for 7 randomly chosen students. So here are their absences and then their final grades. So our college at St. Philip's Alma Colleges, they allow 2 weeks equivalents of absences for any reason without penalty. If you meet like twice a week, then like a Tuesday, Thursday, then that would be 4 days absences. But then anything above that, the student is in danger of being withdrawn for excessive absences. And that's why with like online classes, we keep track of late late homework submission, completions, and the amount of late homeworks submitted that counts as a form of absenteeism, so absences. Um, and so you want to monitor that because then a student could be withdrawn. Of course, if they're not meeting the quiz and test assignments, you have to make 60% or higher. Okay, so just keep that in mind. But these studies often show that a negative linear relationship, that as the x's increase, as the number of absences increase, then the final grade usually also tends to decrease. So as the absences increase, the y's tend to decrease. So let's see if we can see their little plot for that here. Let's see. Yeah, so you see this here. See how we study graphs from left to right. So you see how it looks like you're walking downstairs from left to right. Okay, descending. Okay, so remember we study graphs from left to right. Yeah, so this appears to have a negative linear relationship. Okay, whereas the first one we had a positive linear relationship. Okay. Okay, so then we have more vocabulary. Let's see. So correlation. So there's something called the population correlation coefficient. This is denoted by, this is called rho. This is a Greek letter of the alphabet. Okay. So it's computed by using all the possible pairs of data values X, Y taken from a population. And our TI-84 will calculate that for us, okay? The linear correlation coefficient, which we'll call R, is computed. So let me stress that it's R and not R squared. You want to make use of R and not R squared. So R is our linear correlation coefficient. It's computed from the sample data and measures the strength and the direction of a linear relationship between two quantitative variables. The one explained in this section is called that, look at that long name, PPMC, Pearson Product Moment Correlation Coefficient. So that was named after the mathematician, Pearson, mathematician, last name is Pearson, okay? So the range of the correlation coefficient is from -1 to 1. If there is a strong positive linear relationship between the variables, the value of R will be close to +1. But if there's a strong negative linear relationship between the variables, the value of R will be close to -1. So keep that in mind. And we have a picture of that on this here. Yeah, so see, this is shaded. If it's close to 1, it's a positive, strong positive. See, you shaded close to -1, that value. Yeah, and then if it hovers around 0, then there's actually no linear relationship taking place. And then here's some scatter plots. Here's some ideas of some values of your R. So here the R value is 0.5. Here your R value is 0.9. Okay, so this is close to the strong positive linear relationship. Here this is perfect 1, perfect 1. Here's this perfect negative 1. Here this is a negative 9/10, or you can say negative 90 hundredths. Okay, and then R is equal to negative 0.5. Okay. And then these links should still be active after, you know, hopefully if you saw my Zoom video for 2.4, which I covered scatter plots, but if you needed additional help, these would be extra, like, related, I guess, YouTube links or whatnot that you could look at to help you with that. So you just would have to type that in, though, because this is not an active link on paper. So, and this is a YouTube video here. Okay, so that was what was in your workbook, but you see there's no problems. So I had to supplement with the calculator commands. I had to make this handout supplement the calculator command because this didn't have any calculator commands for the TI-84. And then I had to get a couple problems. So I got these, we made this from the ebook to work with. Okay, so let's go over this handout now, and we're gonna fix things in our calculator. Some of you probably bought new calculators, so we definitely need to set this up. Sometimes there's a need, like when you create a graph or scatter plot or a graph. Sometimes if the graph doesn't come out, it might be because of an error mismatch in your data. The amount of data you put in for the X value should be the same amount of data that you put in for the Y. So if there's a mismatch in the columns, that could be a reason why the graph doesn't appear. Another reason is the window. If you don't fix your window just so, then your graph may not be visible for that reason. But sometimes in the past, in the face-to-face classes, there have been times in the past, and even when I've had our stats go-to tutor is Mrs. Hurd. So there's been times when there's two of us in the classroom and she helps with the calculators also. There have been some times when students' graphs don't come out, but we check the window and we check the data and there's no mismatch. And so sometimes it's still, the graph will not appear. So we just have the students like refresh it by resetting that. So last time in the section 2.4, I had given you instructions to have that as a backup on your toolkit, on your note page. You're allowed a note page, 1 page of data for your quiz. Number 2, double-sided, and you want to have that on there. And also when you take the final, you want to have that in case your graph doesn't come out and you need to reset it, because sometimes you have to reset the calculator. So if you have to reset the calculator, then you would have to complete these steps that we're going to do again if you ever have to reset it. So in this handout, there are these set of steps here that were taken from your taken from your ebook. There's some instructions in your ebook, and what we need is we need these steps right here for this section. So usually we just have to do this one time and we're good to go, unless you ever have to do a reset. If you have to do a reset, then you need to keep an eye and check on this, because you might have to retype this again if you had to have done a reset. Okay. The other thing I was going to mention is when you take your quiz number 2, yes, you're allowed your one double-sided 8.5 by 11 sheet or cheat sheet or toolkit, as we call it, but you're also allowed this handout. I will also let you have this handout out because it will have the calculator commands. And as I mentioned earlier, is once we go through these commands and put this in the calculator, there shouldn't really be a need for you to have to do that again over and over for each problem, unless you do this, unless you have a need to do a reset. If you do a reset, then that's when that would occur. You might have to type that in again. Now, and let me just see if I can remind you on the reset. I think I have that page handy here. Sometimes when we did the reset, it would be something like this. To reset defaults, you press the second, then the plus sign, because that has the memory there. So you see this here, plus sign memory, to the second button. So you would press second, then the memory, then you would select 7, then you would select 2, and then you would select 2 again. And usually that does it. And if it doesn't, then we do this option. So where you would press the second, then the plus sign, but then you would select 7, then select 1, and then select 2. So the only difference is this here. And then those are the two options. And usually one or the other will take care of it. The graph should appear after doing this reset. Okay. If it's not attributed to a mismatch error or a window error. So try that first. Hopefully it's a window error or a mismatch error. And if not, then do this. Okay. So let's start back here with this sheet. So we've got to do these commands right here. So to have the calculator compute and display the correlation coefficient, which is we call R, and the coefficient of determination, as well as the equation of the line, you must set the diagnostics display mode to on and follow these steps. Okay. And so the coefficient of determination, that would be I believe that would be the R squared variable on there, but we're going to make use of the R variable. Okay. So we want to press the second catalog, and the catalog is on top of the 0 here, above the 0. So you want to press the second button, which is here, and then go to 0. See, 0 has catalog. So press the second button, 0. Then all of these words come up. See, ABS, A&D, angle, ANOVA. Okay, and these are alphabetical. So you will actually want to hold the down arrow to scroll faster, and you want to scroll so that you want to press the enter to copy the command to the home screen, press enter to execute the command, and you want to be able to see done. Okay, so we're going to scroll down, use the arrow key to scroll down to diagnostic on. So you want to go to the D's, diagnostics on. See, right now we're in the A's. So use this down arrow key and scroll to D's. Just see there's diagnostic off. You want diagnostic on to scroll down to diagnostic on, and then you want to press enter. And then you want to press enter again. And you should see done. Once you see done, then we're good. That's what you need to do. Okay. All right. So now, oh, and then I'm noticing here that I do have, we were talking about the reset. So it looks like we're talking about the reset defaults. It looks like I have the um, reset that I say like if your scatter plots don't appear, and it's not because of the window and not because of the mismatch, then sometimes you've got to reset that if the graphs don't appear. Okay. Okay. Okay, let's go back to the front page here. So it says that the linear correlation coefficient explained in this section is called the Pearson product moment correlation coefficient, called PPMC. It's named after statistician Carl Pearson, who pioneered the research in this area. So the first thing it says, you want to graph a scatter plot using chapter 2 section 4 instructions. Okay. Okay, so we're going to do that, and that way we can have some data X and Y in the L1 and L2 column, and then we can do this, use these keys, because we'll have data in it already. So let's actually do that. So if I go to the problem, number 14, you see it says draw the scatter plot. So forest fires and acres burned. An environmentalist wants to determine the relationship between the number in thousands of forest fires over the year and the number in hundred thousands of acres burned. The data for 8 recent years are shown. So I count this 1, 2, 3, 4, 5, 6, 7, 8. Describe the relationship. Okay, so we have X, the number of fires, and Y, the number of acres burned. And this is from the National, can read that, Interagency of the Fire Center. Okay. This information in this exercise will be used for exercises 14 in section 10.2, and then also they're going to make use of that in 10.3. Okay, we'll keep that in mind. Okay, so let's go ahead and enter our data class. Let's do that. L1, L2, and let's enter our data. So remember how to do that. We covered this with our scatter plot. So remember, you're gonna have to go to your stat button. So go to stat right here, and you want this one edit. So hit your enter button at the bottom, enter, and you want to clear this data. So go up to the top, hit clear, enter, scroll to the side, go up to the top, hit clear. So don't hit delete. If you hit delete, then you're going to erase your column. Then you'll have to reinstate that with the insert, and tell the calculator what column you want. So yeah, don't hit delete, hit clear, and then enter, and your data will disappear. Where you can use delete is if you type something wrong here, you type the wrong number here, then you can delete, or you can just type over it, and that will also fix that. So let's type in your data: 72, 69, 58, 47, 84, 62, 57, 45. And you can go back and double check that. Okay, and I have a lot of zeros here, and I think it wasn't like that before. I think it's because I changed my mode earlier when I was doing a scientific notation example. I think I'm going to fix that. I'm going to just go to mode. Your calculator probably doesn't do that, but I'm going to just go to mode. See on the float, see how I have this up to 9? I think that's why it's doing that. Let me just come here and hit float and hit enter. That way, that's how it was, I think, before that. And then I'll just, let me do a second quit. Second quit. Yeah, second quit takes me back to that instead of turning it off. A lot of times I do second off, but second quit will also, second and quit will take me back to the screen. Okay, and I'm going to go back to stat and then hit enter because I want my column. See, now I don't have all those decimal places there. Okay, now come back over here and type in this data, 62, 42, 19, 26. And you see how it appears here. I guess it's best to double check here and then hit enter. 51, 15, 30, 15. You can go back and check. Okay. All right, and now we're going to fix our window. So go to window. Okay. And I'm going to put some information here on the side. Let me see. So I'm going to recreate this window. So I'm going to have here what we did in the past with the 2.4s. Remember your teacher went over, I marked the smallest X data value. The smallest X data value looks like it's 45. And then I also marked the smallest Y data value. The smallest Y data value looks like it's 15, right? Okay, then I kept track of the largest. So my largest X data value looks like it's 84. Okay. And my largest Y data value looks like it's 62. Okay. Then on my window, I have X min equals X max equals X scale. And then same thing, Y min, Y max, Y scale. And remember, we leave the X resolution as 1. So I never have a need to change that X resolution. Just leave that alone. Okay, and remember what your 2.4 said. When you scatter plot your X min, your window, you want to find an X, you want to select an X that's smaller than your smallest X data value. So usually we usually do zeros here for that. And your X max, you want something larger than your biggest X, so 84. So I'll do like 100. So don't do like 85 or 86 because then your window will be narrow and you want to be generous with your window. You see those ordered pairs. Your X scale. So let's see, if I look at my data here, if you wanted to, you could use tens, increments of 10, 10, 20, 30, 40, 50, 60. So 10 would work. Also 5 would work. So you have a choice. You could use a 10 or a 5. I'm gonna just go with 10. I wouldn't use 2, like 2, 4, 6, 8, 10. I wouldn't use 100, 100, 200, 300, because see, not you don't have any data that's 100. Definitely don't go shy away from 1,000. Those are scales that we've used in the past. It just depends on what what's the range of your data. Okay, y min, something smaller than 15. So usually I work with zeros for the x min and the y min. Y max, something bigger than your than 62. So you could do like 75 if you wanted to, or even 100 even too. That would be all right. Something bigger than 62. So 75 or 100. And then your Y scale, if you look at your Y's here, okay. So you could again use either 5 or 10, 5 or 10. So you have some choices here. I might, oops, when it goes off like that, just hit the on button. That will take it back to where you have it. Yeah, so I guess 10 would be okay. You could use 10 or 5 here. So 10, 20, 30, 40, 50. Yeah, so 10 would be okay. Now, we can see here, there's a small little answer key. If I can enlarge this, let's see. There's a small little answer key. And sometimes, if you have a multiple choice graph, you can also determine your X scales and your Y scale from looking at your multiple choice graphs and what the computer used. You can see here for the X, they use increments of 10, see, 40, 50, 60, 70, 80, 90. So you can tell here that they use an X scale of 10, increments of 10. And here 10, 20, 30, 40, 50, 60. They also use a Y scale that has increments of 10. Okay, so you can tell. So that's fine. Now they didn't start at 0. Our graph is going to start at 0, and that's fine. They didn't. It looks like they started like x min and y min. So you see that this is not starting off at 10. This is starting here at 40 here for the y's. But that's okay. And their smallest x, their x min where we did 0, they looks like they started that at 40. That's fine. It's okay. So we use 0. So let's type these in, and we should get a picture similar to the picture that's there. Something similar. So let's see. So type in your x min, which is 0, your x max, which is 100, the x scale, which is 10, y min, which is 0, y max, which is 100, y scale, which is 10. Then hit enter. This is good. Okay, so actually we're fine. So already, because we did 2.4, you already should have your second scatter plot on. You should just be able to hit graph, and a graph should appear because we've got this set up. Okay, and I have a little graph that shows up here. And if I do my trace will, and if I move this arrow right here, my right arrow, it will kind of tell me the coordinates of my ordered pair. See that? So you can identify them. Okay. So, and sometimes that will help you when you identify those. So let's see. So this is similar to this. Let's see, this is my fingers here, my index fingers. That's just going on here. Okay. There you go. All right. So it it does look like there's like a somewhat of like a relationship here. If you think of drawing a line through these points here, it does look like there's like a little bit of a positive linear relationship here. It's not like they're scattered all over the place like in our section 2.4 here where you have no relationship here all over the place. So it looks like um, a slight positive linear relationship. See, this is a negative relationship. Okay. Sometimes your calculator will draw a line through the points for you, and it's not doing it, at least not yet. After we do our first problem, though, I think that line will start appearing, like the line of best fit. So, but there seems to be a type of a positive linear relationship taking place here. Okay, so now just keep that in mind. Okay, so then we're going to follow that thought and then defend it with statistical measures now. Okay, but that's what they want you to do on the first part. And then you're probably going to have a multiple choice graph choice to pick out the one that's the best fit. So you have this on your calculator to do that. So that's part A. Okay, part B, they want you to compute the value of the correlation coefficient. And then part C, they want you to state the hypothesis. Okay, so for part B, we want to get that off our calculator. Compute the value of the correlation coefficient. So that would be R. Put a comma here. That would be R. Okay. Okay, so let's see if we can find that. So let me put this here. B. So let's see if we could find out what the correlation coefficient of R is in our calculator. Okay, so this is where we're going to go back to that handout for those calculator commands right here. So we already did the scatter plot. Okay, so we did put our data in already. Okay, and we have our scatter plot. Okay, so we're using the linear regression t-test. This features to find the correlation coefficient, or R. So you would enter stat and you would tab over twice. See, tab over twice to access the test menus. Then you want to use the down arrow key, or you can use the alpha and then the cosine key. And it says here F to select the linear regression test and press enter. So it looks like when you go through your tests, you're going to have a list of like A, like you might even have numbers like 0 through 9, and then A through probably A through Z probably. And you want to look for F because F is the one related to the linear regression test. If you wanted to go through it faster and you didn't want to do a scroll like this, they're saying that if you press the alpha key and then the cosine, that should take you to the F faster. So let's explore that. Okay, so turn this thing back on and we should go to the stat button. So go to your stat button and tap twice and you're at test. So the long way is to go all the way down until so you're going to go through like numbers 1 through 9 and then 0 and then A, B, C, D, E, F. Whoops. And then you hit enter. Okay. Then you're going to work with that. And I believe that that screen is right here. Okay. Or what you can do is if I go to Stat and I tab to Test, the faster way is to go to, this says alpha, see, alpha cosine. So alpha is right here in green, and then cosine, see how there's an F right there in green? See, there's an F. See, and you want to get to F. See that? So the faster way, rather than scroll down, is to hit the alpha and the cosine, and you see that takes you to that exact same page there. Okay. Okay. So then, what else does it say? So we did enter our data. I have a note here that we did enter our data correctly in L1 and L2. So here we're identifying where do we put our data. We did put X in L1, we did put Y in L2. If you use other columns like L sub 3, then you'd have to, you know, if you put the data in other columns, you'd have to identify where you put the X and Y data. So let's just say I need to change it. Just say I have put the data in L3. The way you would change it is you would hit the second button right here. And like, let's say I hit number 3. If I look at number 3, see how it has L3? So when I hit 3, see how that changes that to L3? Okay, so but for us, our data, our X data was in L1. So I'm going to change that backspace, do the second button, and then hit number 1. You can see number 1 has L1. That's what you want. Okay. Okay. So let's see. So now we're at this part here. Enter L1 for the X list, enter L2 for the Y list. So we did that. We're telling our calculator where we put the X data and the Y data, and that's talking about this over here. Oops. See the X and the Y and the L1 and the L2. That's what that's talking about. And then after that, you want to enter L2 for the Y list. So let's see. Okay, we did that. And then for regression equation, you want to press, and remember I was talking about a line that will go through that. They're talking about that line that go to the best fit. Regression equation, press the vars button, and the vars it's located in between these keys, the program and the clear. So let's see, here's your program and here's your clear. See that vars? So you want to hit the press the vars button. That's what that says. For a regression equation, press the vars button. Okay. And then use the arrow key to go to Y vars. Okay, so you want to use this arrow key right here, and you want to go to Y vars. Press the enter to activate one function. So you see you want that, see? So hit press the enter. And then you're going to press enter again to activate this 1Y1. So you see it's already highlighted. So hit enter again, hit enter again. And then it says, so I don't like how my L2 disappeared. I don't think that was supposed to happen. My L2. Let's see. I'm going to go back and put, did yours disappear? I'm going to do second L2. Okay. So I'm going to go back and do this. So for regression equation, you see. Oh. Yeah, so I don't think it matters at what point I put this in. If I just go to the vars key, just go to the vars key, tab to the right, right? Hit enter, hit enter. Yeah. What what that does is what that does is that puts this y1 here. So, but since see how that frequency disappeared, I don't think I want that frequency to disappear. See how that has to be 1? So I think what happens is I actually have to scroll down here to regression equation. So if you have a brand new calculator, your regression equation is probably empty right now. I have used this in the past. Have used this, so that's probably why I have already a Y1 from previous semesters. Okay, so here is where you would do on the regression equation where it would be empty for most students. We have a brand new calculator. Then you would press the vars key here. Then you would tab to the Y vars and then do 1 and then hit enter. And what that does is that's what you want here. Because you don't want these to disappear. You need those. And you can tell because see these graphs here? See, they don't disappear. Now, see how it's empty here? Regression equation. And now look how you have y1. That's what you want here. Now, I have a notice about this though. This is important here. In the past, sometimes students wouldn't get the right R value. And the reason why is because this is offset here. This this is hypothesis testing. We're doing hypothesis testing on our TI-84. This first one is for two-tailed test, which is what we're working with today. This is a left tail test, and this is a right tail test. And so it does make a difference, like what test you're using. And so this symbol needs to be marked not equal to 0 symbol. And it says that here that we need this alpha not equal to 0 highlighted. Not this, you don't want this highlighted, the left tail test or the right tail test on the TI-84. So you don't want this and you don't want that. Instead, you want this highlighted here for the two-tailed test, which is what we're doing. Okay, so it says here we need alpha, which is the row not equal to 0 highlighted, not this other option or this option on the TI-84. So you just, I'm gonna just put on the wrong spot. Oops, let me come over here. So like you don't want this highlighted here. If you have that highlighted, your R value generated will be different. If you have this highlighted, your R value will be different. So you want, we're doing, this is a called a need for two-tailed testing. So you need to make sure that is highlighted, okay? Not left-tailed and not right-tailed. So this points to the left, this points to the right, left-tailed, right-tailed testing. Okay, so we want this here, two-tailed test. And then we already got this done. So now we should just hit calculate. Tab down using the arrow key to calculate and press enter. And when you do that, you might have to press enter several times maybe because uh, this I have for 14D and 16D, you want your row value. But over here for 14B, which is what we're working on now, and 16B, you want your R, your correlation coefficient. So you see your R. They give you R squared also, but what we need for this section right now with the correlation is we need to grab our R value. Okay, so go ahead and then you would round to whatever place value they tell you to round off to. So what we're going to do um, on our problem is remind you, see, we're computing the value of the correlation coefficient R. So we want to find our R value on our calculator. So now we just come here to calculate and hit enter. And then this is an equation, kind of like y equals mx plus b, the slope of a line, which we'll make use of for regression. We'll make use of that later for quiz 3. But for now, there's our row value that we do need to calculate that. We do need to jot that down a little bit for part D. When we're doing the decision rule test, we will need to compare the probability value, that row value, and compare that in the decision rule using the alpha that they specify. Okay, but for now we don't need that right this second. So let me go back down. And this A and B is for part of your slope here of this equation, regression equation. So let's keep going down. And be careful, you don't want to use r squared. So r squared, when they were talking about the variables, that was r squared was this coefficient of determination, but we want just the correlation coefficient r. So we don't want r squared, so just be careful with that and go down. And there's our r, okay? And we're going to look at the strength of that r using that picture that we saw earlier. So let's write down that r value. Point 7705 01421. And oftentimes they'll tell you what to round to. They'll say round to 3 decimal places, or round to 4 decimal places, or round to the thousands. Here they didn't tell us here specifically what to round to, but remember I have a little answer key here. And oftentimes that's what happens. I have to work backwards. I can tell from this R, see, tens, hundreds, thousands, tens, hundreds, thousands. I can tell they rounded that to nearest thousands. So I'm going to say round to the thousands. When you take your quiz, though, your Connect Math is real good about telling you what to round to, what place value to round to. And it will oftentimes change it. Like it may not be consistent. Like you may not round all the different answers to the same place value. So you just have to read the directions on that, what place value. But here we're going to round to 1,000. So tens, hundreds, thousands. Can you look at the neighbor to the right? Is that neighbor 5 or more? Yes. So you're going to add 1 to this. So R is approximately 0.771. And remember, that's what they had. Remember how I had that here? See that? Let me check that. Okay. Now, as far as the strength of that, because the next part C is to state the hypothesis. So let me go to some more reading. So I think I'm going to skip step 4 for now because I have R on my paper right now and I want to talk about the strength of R. So I think I'm going to actually go to number 5 instead and read this. Okay. So it says, so you would tap down about 4 times, and we did that. Remember, we went down with this arrow about 4 times to find and record the R, which is the sample correlation coefficient, to the nearest thousands place value. So you want R, not R squared. So statisticians use the measure called the correlation coefficient to determine the strength of the linear relationship between two variables. This linear correlation coefficient R is computed from the sample data, and it measures the strength and it measures the direction of a linear relationship between two quantitative variables, okay, as opposed to qualitative variables. The range of the linear correlation coefficient is from -1 to 1. If there is a strong positive linear relationship between the variables, the value of R will be close to 1. If there is a strong negative relationship between the variables, then the value of R will be close to -1. When there is no linear relationship between the variables, or only a weak relationship, then the value of R will be close to 0. When the value of R is close to 0, or is exactly 0, then it implies that only there is no linear relationship between the variables, and the data must be related in some other nonlinear way. So remember, our value was 0.771. So you see, here's 0.5. So somewhere here, right? 0.771 is beyond 0.5. So we would say it's considered a strong linear relationship. Okay. So now you first saw a scatter plot that looked like it had a positive linear relationship, and now you found this R value, this correlation coefficient, and that looks like it's a fairly strong positive linear relationship. So fairly strong. Okay, right? All right, so that's looking good. Okay, so now we go to C, and part C says they want you to state the hypothesis. State the hypothesis. Okay, let's state the hypothesis. Excuse me. Okay, so let me read the information about the hypothesis on this handout right here. So, okay, we're talking about the population coefficient rho. Okay, so we haven't recorded that yet, but that's this. So I'm going to hold off on that sentence. Let's see. But let me go to step 6 though. Okay. State the hypothesis. So since the value of R is not equal to 0, yeah, and we got like 0.771, 771 thousandths. Either the value of R is high enough to conclude that there is a significant linear relationship between the two variables, or the value of R is just due to chance. To make this decision, you use a hypothesis testing procedure. The sample correlation coefficient can then be used as an estimator of our rho value. So see this right here. That's the Greek letter rho value. If the following assumptions are valid, the data are quantitative and are obtained from a simple random sample, very important. The scatter plot shows that the data are approximately linearly related. Okay, and that was kind of what was happening, remember, on our scatter plot. It's kind of showing that. Number 3, there are no outliers in the data. Number 4, the variables x and y must come from normally distributed populations. So in this book, the assumptions will be stated in the exercises. However, when encountering statistics in other situations, you must check to see that the assumptions have been uh, met before proceeding. Okay. So, yeah, so in our book, do they say anything about the assumptions? Let me see. Let me go back and see if they say anything about the assumptions. They, I believe in the ebook. Let me just check real quick. I believe they make a comment about that. Let me just check that real quick. Let me go to 10.1. Just to show you. No, I don't see that in here. Let's see. I thought they used to have a comment and they would say that. Oh yeah, it does. It does. I missed it. Look, it's right here. Look, it's real small. Here it is. Let me highlight that. See, assume all assumptions have been met. Yeah, so I was trying to go to the ebook and I was trying to see that comment in 10.1 and then I I realized that it's right there. It says it there. Okay. So let's see. So we're talking about the hypothesis. This is what we're leading up to, how to set it up. Okay, so in hypothesis testing, and we're doing a two-tail hypothesis test as opposed to the left tail or the right tail testing, one of these hypotheses is true for two-tail test. Okay, so one of these is true, and we got to figure out which one we want to go with. So here, this is called the null hypothesis. H sub 0 is called a null hypothesis, and this is your row. So this is this probability value. This is called rho. That's the Greek letter of the alphabet. Rho is equal to 0. So this null hypothesis means that there is no correlation between the x and y variables in the population. Whereas this h sub 1, and this is rho not equal to 0, this is an alternative hypothesis, meaning that um, there is a significant correlation between the x and y variables, okay, in the population, okay. And then I have a note here that some age journals use H sub A, not H sub 1. H sub A means alternative. So make use of that because before they used to encourage us to use H sub A as opposed to H sub 1. And so that's recently changed. So they prefer H sub 1 now for the most part when they use that. It's an alternative hypothesis. Okay. All right. So what I'm going to do is I'm going to write these down. They want you to, one of the things they want you to do is state the hypothesis. And this, in all your problems that you do on your homework, and we're going to do this on number 14 and number 16, when it comes time to stating the hypothesis class, feel comfortable always writing these two statements down. For what we're doing in this two-tail testing, this will be your setup for a hypothesis test. Okay, so I'm going to go to my paper and write that down. Excuse me. Excuse me. H sub 0. So my rho is like a P is equal to 0. H sub 1, my rho not equal to 0. Okay. Yeah, to continue reading the page here. So it says that when the null hypothesis is rejected at a specific level, it means that there is a significant difference between the values of R and 0. When the null hypothesis is not rejected, then it means that the value of R is not significantly different from 0 and is probably due to chance. Okay. All right. So that's what you'll do is you'll type that in for your hypothesis. And the computer might help you. The computer might have some of this in. It might just want you to decide on these statements here. So remember this is the null because it's got 0 that has the equals, whereas the alternative has the not equal to. Okay. Okay, now I'm going to go to D. And D says they want you to test the significance of the correlation coefficient at alpha equals 0.05. Okay, that's important. Okay, so D is, I'm going to put here, we're going to test the significance using the decision rule. Okay, excuse me. Okay, now let me talk about that now. Let me write this down here in this paper, and then I'm going to go back and read that. So I'm getting this from our paper. So we have our rho value less than or equal to our alpha, or we have a rho value greater than alpha. All right. Okay, got it. Okay, so let me go back to our paper and where is this coming from? Is this decision rule is coming from this. When the null hypothesis is not rejected, it means that the value of R is not significantly different from 0. It's probably due to chance. Make the decision using the decision rule when using a probability value, a rho value. Here, if our P or rho value is less than or equal to alpha, we're supposed to reject the null hypothesis. But if our probability value is greater than alpha, then do not reject the null hypothesis. Okay. That is why, because that is why I wrote this down here. That's why I wrote that down here. Okay, now let's talk about the alpha levels. You want to be careful because sometimes people miss the problems because they always think that the alpha is always this in it. And maybe for your homework problems, maybe it is uh, 0.05 500ths for these two particular problems. But your quiz, when you take your quiz, the computer has the right to change the alpha level. And usually it's just limited to these two. But you do need to identify and record the common alpha level used. It may be 500ths, it may be 100th. Okay, the choice of the level depends on the seriousness of what they call, excuse me, a type 1 error. Okay, so for us, our alpha is 500ths. Okay, so you want to come over here, and our alpha is 0.05. Okay. Okay, and that's what was given on problem number 14 and 16. 14 and 16. So you can see they're telling you to use the 0.05, which I did. See how I substituted that there? In lieu of alpha, I substituted that. But you want to stay alert when you take your quiz and when you do your homework. The computer has the right to change the alpha level. And when it does, you want to keep an eye on it because then you'll have to use the other value that they assign when you do your substitution. So just be careful with that. Okay. All right. Then now we need our probability value or row value so that we can get that from our calculator. Let's go back, turn this thing on, and let's see if we can find it. I think I'm going to have to go back up. There it is. Excuse me. See that value right there? See that? That's our row value. We need that. Write that down. Okay. So it's 0.0252. 63 255. All right. Okay. Now, I know that's really long. So, um, in your when you take your quiz, it should ask like it should ask for the probability value. And so, let me write that in here. So remember, let me write this in here. So we also saw this here in our workbook. See, they might call it the population correlation coefficient. See that? And R is the linear correlation coefficient. So let me go back and do that. So for R, I did have correlation coefficient. I'm going to just add the word linear to that. And then here, for rho, that's the Greek letter. Rho is the Greek letter. That's also called the population correlation coefficient. I'm also going to coin it also probability value also. You can write that down, please. Write that down, please. Sorry. Okay. And I'm going to just, because it's really long, and I think that'd be okay. When you answer your problems on your quiz, where they specifically say, I believe they say, like what's the probability value or what's the population correlation coefficient. You want to have those synonyms down, how they word it, which way do they ask for this row value. If they say round to a certain place value, then round. If I round this to the, like I did earlier, to the thousands, tens, hundreds, thousands, and then you look at the number to the right, the neighbor to the right, is that neighbor 5 or more? So I round this to the nearest thousands, tens, hundreds, thousands. And I look at the neighbor. Is that neighbor 5 or more? No, it's not. So don't increase that. So this just becomes approximately 0.025. Okay. Approximately 0.025. Not 0.026. No, not. You don't increase it by one, it stays. But you're comparing that now with the alpha of 0.05. Okay, so we come back over here and put that value in here too. So do you understand what I'm doing? I am substituting the correct value for my probability value, for my population correlation coefficient value. Do you see that? You need to be careful because sometimes the mistake that's made is on from part B, they have the R. They will substitute on accident the value R. So you want to be real careful. You don't want to be substituting the value R in this decision rule. You need to be substituting the probability value coefficient, the population correlation coefficient value into that. Okay, it's super important. And then it says, is it, and then only one inequality can be true. They cannot be true. One's going to be true, one's going to be false. So you need you need the one that's true. So now let's see which one's true. There's this one to look at, and there's this one to look at. And so this one, if I compare this one and I look at um, the tens place, excuse me, that's the ones place value, the ones place value, they're the same. So remember in your rounding, I happen to have a rounding chart here. So remember on your rounding chart, see here's your and, see that's the ones. See decimals will start there. So that's ones, tens. This way, after decimals, tenths, hundreds. So it starts with ones, tens. So here you start with the ones place value and they're tied. They're both 0. Okay, then you look at the tens place value and they're tied. They're both 0. Then you look at the hundreds place value. This is a 2. This is a 5. And you see that 2 is what in comparison to 5? You remember you read inequalities from left to right also, just like you read graphs from left to right. Remember that we read inequalities from left to right. we re-inequalize from left to right. So this is saying that this 2 is less than 5. It's not equal to, but it is less than. So this is true because this is the symbol less than. The 2 is less than or equal to 5. So all you need is 1. It's less than or equal to. All you need is 1 for it to be true. So the one that's true is that it's less than. It's less than. 2 is less than 5. 2 is less than 5. So that means this one's true then. Okay. So let me see how I highlighted that. Yeah, what I did was I like boxed that. So I boxed that one. See, either this one or this one's going to be true. Not both of them can be true. And let me also write this down. Yeah, so this is the one. This is the one that's true. Okay. This one's going to be false. Let's double check and make sure that one's false. So on this other one, if you compare so the one's place value, they're both 0. After the decimal, you have the tenths place value, they're both 0. And then you go to hundreds place value, and 2 is compared. 2 is what in comparison to 5? See, this one's false. This p-value, is that true or false? Is this p-value greater than 5? This is false. This this hundreds, tens, hundreds, this hundreds place value. 2 is not 2 is not 2 is not greater than 5. 2 is not greater than 5. This 2 is not greater than this 5. That's false. That's false. So you cannot go with this. You cannot go with this one. You can't exit out. Cannot go with that one. So only that's why they call it a decision rule. They call it a decision rule, and then we're using statistical significance. So remember performing hypothesis testing using statistical methods and working with correlation problems. So this is part of the statistical methods here. So you cannot, when you make your decision rule, only you have to make a decision, only one of them is true. They cannot both be true. So you need to make sure though that you have your correct value. See, you need a probability value, a p-value, you need an alpha level, and they're always going to be changing up the alpha levels. It won't always be in this problem. Our alpha level is 0.05, but remember what I said in the literature, that they can change it to 0.05 or 0.01. So in statistics, you always have to read and reread the problems and read those applications, and they have the right to change the alpha level, and you need to keep track of that, because when you put your alpha level here, you need to be substituting that alpha value there appropriately. Okay, and so we were substituting 0.05 because that's what they told us to use for this particular problem, number 14. And then you get your p-value from the calculator. So remember, we got the p-value from our calculator here. If for some reason, if you're not getting the same values as us, it could be that when you typed your data, it could be when you typed your data that if one number is off, then that can change a p-value. So you need to make sure that you go back and check your data. Um, the other thing that can happen is when you do your, remember we did stats, and remember you tabbed to tests, and I went to alpha cosine, alpha cosine. The other thing, remember, is if this is in the wrong test hypothesis testing. This is, see how this points to the left tail, right tail. Remember, literature said this is an example. We need two tail tests here. If this is not marked correctly, then you will get different values. Okay, but other than that, you know, when you calculate and you scroll down like what, 4 times, 1, 2, 3. Don't use r squared. 4, there's your r value. And then where was the p? There's your r value for the strength of the correlation. That was for the strength of the correlation on the correlation problems. That's the strength. 0.771 is closer to 1 than to 0. That's pretty strong relationship there. Where was our p-value? But go back up. There's our p-value. There's your p-value, probability value. And then I just rounded that, I think, to the nearest, was it the nearest thousands that I used? I could have also used the nearest hundreds too. I could have used the hundreds. See, this is in the hundreds place. So I could have also used the hundreds place also. But that's fine. I used 1,000, so that's okay. Because the thing is, if I used hundreds, if I rounded this to hundreds, this would have been 0.03. So I would have been comparing 0.03 to this. So 0.03. Still, even if this had gone up to 3, this 3 is less than 5. So this still would win. Whereas over here, you'd have 0.03. And a 3 is not greater than 5. So you still have to X that decision rule out, X that out. So you have to be careful. All right. So now that we know that we're going with this one, our p-value is less than or equal to alpha. Now you have to go to summarizing. See which one was true. This the first one, the second one. This one was true. This one was false. So look what I have to write. Since this one was true, our p-value was less than or equal to alpha. We have to say that we're going to reject the null hypothesis. Okay, so we have to say, because this is true, you have to say reject the null hypothesis, and the reason why is due to your p-value being less than or equal to the alpha. So you have 0.025 is less than or equal to 0.05. So you have to highlight that in pink. You have to reject. Okay. Okay. All right. So again, these are two decisions. You have to make your decision, and we went with the first one. The first one was true. The second one was false. And because the first one was true, look what it says. You have to reject the null. Reject the null. Okay. So now what does that mean to reject the null? So now we're to this part now. We already tested the significant. Now we're going to give a brief explanation about the relationship. So remember, we saw the scatter plot was a positive linear relationship. And then we saw the strength of R, 0.771, which was a pretty strong linear relationship. Okay. Okay, so both of these are good. What's not strong is if it's around here, right? That's not strong. But these are 0.771 is strong. So you had a systems go on, yeah, a linear relationship. And now we have the statistical part using statistical methods and the hypothesis testing. So now here's our summary. So now that's this handout here, summarizing the results. Okay. Okay, so remember we went with reject the null. Okay. So let's see, we want to read this one. See, reject the null. We don't want to read this one, not reject the null. We're leaning towards this, reject the null. That's what we said. We're going to reject the null. Okay. So remember your two choices again. See, to the decision rule, which one's true, which one's false. Go with the one that's true. For us, this was true, so you reject the null. If we had gone with this one, if this had been true, then you would have gone with do not reject the null. But since we went with this is true, reject the null. So you want to go with this paragraph then. When the decision is made to reject the null hypothesis, which they call H sub 0, because your probability value is less than or equal to the alpha, then we summarize the results by saying that there is enough evidence to support the claim. So what does that mean? In other words, when we reject the null hypothesis, H sub 0, then we summarize that there is a significant relationship between the x and the y variables. Okay, so I'm going to write that down here because it says here, give a brief explanation of the type of relationship. So we're leaning towards, because we rejected the null, we're saying there's a significant relationship between the x and y variables. So remember, your x variable is the number of fires, the y variables is the number of acres burned. And again, if you look at this, remember these are little answers that we have here. See what it says? There is a significant linear relationship between the number of forest fires and the number of acres burned. So you conclude that there is a, a significant linear relationship between the forest fires and the acres burned. Okay, I'm going to actually highlight that. I don't really have room to write that down here at the bottom, but it's saying the same things. There is a significant relationship between the x and y variables, and that's what they're saying here. There is a significant linear relationship between the number of forest fires, which is the x, and the number of acres, which is the y. Okay. So I'm going to draw an arrow I'm gonna draw an arrow. So I'm gonna draw an arrow from here, from here, all the way back to there, so I don't have to rewrite that. So I'm putting an arrow here all the way back to that. That's what we needed there, okay? All right. All right, so I'm going to stop this recording now, and then tomorrow I'll do another recording, and then I will work out number 16. And number 16 is supposed to display the other scenario where the other decision rule is true, and then there would be no relationship, no linear relationship between the variables. And I think, let's see, there might be one more thing I want to read. I pretty much read almost everything on this handout here. I think the only thing I skipped was just step 4. Let me just go back to step 4. Um, because step 4 was talking about this this population correlation coefficient, the probability value. So they do mention that, okay, they mention that here. The population correlation coefficient denoted by the Greek letter rho is the correlation computed by using all possible pairs of data values x and y taken from the population. So I think we read that from the workbook also. But then over here it said, when you find and record the p-value to the nearest thousands, or whatever place value the Connect Math asks. Sometimes it might ask for the tenths place value also, but the probability value is the probability of getting a sample statistic, such as the mean, for example, which is noted as mu, or more extreme sample statistics in the direction of the alternative hypothesis, when the null hypothesis is true. In other words, the p-value is the actual area under the standard normal distribution curve or other curves, depending on what statistical test is being used, representing the probability of a particular sample statistics or a more extreme sample statistic occurring is null, is the null hypo if the null hypothesis is true. Okay. Okay. So I just wanted to mention that because I hadn't read that out loud. Okay, so I'm gonna stop there, and then next time when I do a recording tomorrow, I will demonstrate number 16 to show you that. Okay, but meantime, you have something once this is posted, right, in your Canvas course, you'll have something to look at to supplement your ebook reading and to supplement like whatever little video. The videos are prerequisite to starting your homework, and it's usually related to what you're working with. So then this video is to supplement that. Okay, and then remember, after you see this video, and then also when I do the second video, if you have questions on your homework on Connect Math, and remember you need to plan to make use of MathRow. MathRow, I have a link in your Canvas course, and usually Trudy, Mrs. Hurd, Trudy, Trudy, she's usually our go-to person only because she has sat in my classes numerous times, and also Mr. Trotman, to better tutor students. So she's been paid to sit in our classes and assist with the calculator usage in class and observe. And she's available for tutoring because she's the go-to person because she's been assigned to sit in our classes to assist. So so don't feel like you're imposing. If you need help, if just you want to go into the math row links and receive that. Okay? All right, so good luck with your work then.